Hello, fifth graders. Mr. Wayner here. Today is February 18. This is your homework for Wednesday, February 18 here, just to watch this video along with completing about a dozen questions on a page that was distributed in class today. Just some concepts that I'd like to go over, reviewing today's material and kind of doing a little bit of pre-teaching for tomorrow. I want you to have some background knowledge before you come to class. So I'm just going to go over a couple problems here. I'd like for you to just track along with what I'm doing, and we'll go forward from there. Now, today in class, we talked about when we added problems like 1 and 2/5 and 2 and 4/5 together. We said when those were added, we solved this problem just like we solved 81 plus 2. We do our ones column first, and then we follow that by the tens column. So in this problem, we would say 2 plus 1 is 3, and 8 plus nothing is 8. So 83, 8 representing the tens column of 80. The same thing happens when we look at these fractions. Now when we add together 2/5 and 4/5, that comes out to be 6/5. When we add our 1 and our 2, that added together is 3. Now 3 and 6/5 is an answer, and it is acceptable. However, there's another answer that we can come to that makes more sense in the real world. When we look at the 6/5, there's a way that we can simplify this. If I were to take this apart, I could see that this is 5/5 and 1/5 added together. Now 5/5 is the same thing as 1 whole. So 6/5 is really the same thing as 1. And if I can get my pencil working here, that would be great. 1 and 1/5. These two things are equivalent. I know that this screen's a little blurry right now. The 6/5 is the same thing as 1 and 1/5. Knowing this, I can add my 3 and my 1 and 1/5 together to equal 4 and 1/5. Now, I kind of talked through, this is a sloppy copy here of my work, but this helps you see all the steps that I went through when solving this problem. Let's try one more. Looking at this next problem, 3 and 3/5, and adding on 2 and 3/5, I can see that when I add up my fractions, I already have the same denominator, so I don't need to make any changes, but 3/5 plus 3/5 is 6/5, and 3 plus 2 is 5. Now I know that 5/5 is equal to 1 whole. Whenever the numerator and denominator are the same, that equals 1 whole. So I could think about taking 1 whole away from this amount right here, the 6/5, taking away 5/5, and being left with 1/5. Now I just added this 1 whole value, this 5/5. So this 5, 1 is added on. So my final answer is 6 and 1/5. Now sometimes we have problems like 2 and 1/2 and 3 and 1/4 that we can't necessarily add together because the denominators are different. Just like when we added and subtracted fractions before with unlike denominators, we need to change a fraction or two to make it so the denominators are the same. In this case, I see that I have 1/2 and a 1/4. Now I know that if I multiply my 1/2, my denominator by 2, and my numerator by 2, I'll end up with 2/4. So the denominators are now the same. Sometimes you might need to multiply the denominators by the opposite denominator to come up with fractions that have the same denominator. Once I've done this step, I then can add my fractions together. I can add my 2/4 and 1/4, which all together equal 3/4, and my whole numbers together, my 2 and my 3, for a total of 5 and 3/4. Now on occasion there will be times where you have two different fractions, like 1 and 4/7 and 2 and 1/10, where the denominators don't match up together. See, here we have a 7 and here we have a 10. Now when adding these together, we always need to have the same denominator, but in this case there really isn't an easy way to do that. I can't multiply 7 by 3 and get a multiple of 10. That just doesn't work. So in this case I'm going to multiply by the opposite denominator. In this case it will be 7 times 10 and 4 times 10 and 1 times 7 and 10 times 7. See how I took the opposite denominator and multiplied both the numerator and the denominator of the other fraction. When I multiply this out, I have 1 and 40/70ths and 2 and 7/70ths. Now when I go to add these together, it's much easier because I have the same denominator in both of these problems. They both have 70ths now. When I multiply my fractions together first, my 40/70ths and my 7/70ths, I come to a total of 47/70ths. Remember, the numerators add together, but the denominators just stay the same. When I multiply my whole numbers together, my 1 and my 2, that equals 3. Now this is where a little bit of pre-teaching happens for tomorrow. Tomorrow we're going to be talking about subtracting these mixed numbers where the denominators aren't always the same. So I'm going to show you one example today. So you're kind of thinking about and processing what does this mean when I'm subtracting these two amounts. Suppose I have 5 and 7/8 and I subtract 4 and 1/2. Just like when I added the two fractions together, I want the fractions to have the same denominator. In this case, I'll multiply my 1/2 by 4, both the numerator and the denominator. So my new fraction will have the same denominator as the fraction listed above. So I have 4/8, 4 and 4/8. I'm going to rewrite this up to the right here so it's a clear image of what this problem looks like. 5 and 7/8 minus 4 and 4/8. Just like before, I take my first fraction and I take the 7/8 and I subtract the 4/8. Now sometimes this is a little bit confusing because we look at the subtraction problem, we say, Mr. Weiner, I have no idea what I need to do here. Just as we did before though, we just take our first numerator and subtract the second. The denominator stays the same. So 7 minus 4 is 3, and the 8s stay the same. So my fraction component is 3/8. Now my whole numbers, 5 minus 4, which is 1. Now there will be an occasional problem that comes along, like 1 and 1/2. We'll actually make that 4 and 1/2. Minus 1 and 3/4. In this problem, I first want to have the denominators be all the same value, the same amount. And so I look at the top and I say, you know, this is me thinking aloud here. I see that I have halves and I have fourths. And I say, you know, I know that I can get my halves into fourths by multiplying by 2. And I do that, and I multiply both the numerator and the denominator by 2. So I have 4 and 2/4 now. I subtract 1 and 3/4. Now many of you like to look at this problem and say, well, I see a 3/4 and a 2/4, so I'm just going to take 2/4 away from the 3/4. Well, in this problem that's not necessarily the case. We're taking 3/4 away from the 2/4. And just like in subtraction, when we have a problem like 81 minus 12, we can't take 1 away from 2. We need to take the 2 away from the 1, and we need to borrow. So we need to cross out the 8 and replace the 1 with an 11. And subtract 2 from the 11, which would be 9. And 7 minus 1, which would be the 6. Likewise, pardon me, 5th graders, as I'm being distracted here by Mrs. DeLoof and Mr. Karsten. They're being very distracting as I'm making this video. You can give them a hard time in band and ASP for their ability to distract me. Anyway, back on the ranch. So we have 2/4 minus 3/4. Well, we need to borrow from the 3, and we can cross it out and from the 4 and make it a 3. Now, we all know that 1 whole equals 4/4, so I can add the 4/4 onto the 2/4, and this would turn into 6/4. And now 3 and 6/4. Like before, we take the fraction and we subtract the fractions first. 6/4 minus 3/4 is 3/4. And 3 minus 1 equals 2 for a grand answer of 2 3/4. This is just for you to start thinking about what this process is like and how we solve these types of problems. Now that you've watched the whole video, I'd like for you to send me an email and just say, Mr. Wehner, I have watched the video, and this is how you will receive credit for tonight's homework assignment. Thank you so much, and enjoy the rest of your afternoon. Bye-bye.